Okay, in this video we're going to look at combinations, permutations, factorials in Excel, and look at a couple of problems similar to the homework. First of all, in Excel, if you want to do a factorial, in other words, we all know that 4 factorial is equal to 4 times 3 times 2 times 1, which is 24. If you wanted to do that in Excel, you could just say equals F-A-C-T, double click here, factorial. What is 4 factorial? Boom. It's 24. Now, let's say you wanted to do a combination. Let's see, NCR. We want to do a combination. Let's say we like 5C3. In Excel, we would just say equals COBI. It's the first 6 letters of combination. Double click. Put in your number 5, comma 3, a combination of 5, picking 3. How many different ways can we do it? 10. All right, let's say we wanted to do NPRs. Let's say like 10P4, okay? In Excel, we would just say equals P-E-R-M-U-T, permut, which is just the first 6 letters of permutation. We put in our 10, comma, 4, close that parentheses, 5,040 ways. Okay, so in this question that I got a number 13 of the homework, it said evaluate the given expression, and it was 55P2. So to do this in Excel, really easy, equals P-E-R-M-U-T, permut, now, open 55, comma, 2, close that parentheses, 2,970. That's the answer. It's that easy. There's the formula again, equals permut, open parentheses, 55, comma, 2, close parentheses. It's the first 6 letters of permutation. Let's take a look at the next one. The next question, let's see if I can take a picture of it and bring it over. Take a picture, paste it right here. Perform the indicated calculation, 9C3 divided by 13C3. This is what I would do. I would come out here and just make myself a little note, 9C3, 13C3, and then of course down below it we're going to divide, but let's do 9C3 first, equals combination 9, comma 3. You could do this all in one step, but I'm going to show you how to do it this way so you can see both. Combination, got to put the equal sign, C-O-M, here it is, 13 taken 3, 13, comma 3, close that parentheses. So, let's equals this number divided by this number, enter, 0.2937. If we round that to 3 decimal places, format cells, number, 3 decimals, okay. I could have done it all in one step, in other words, equals. I just don't want you to get your parentheses mixed up. Open parentheses, combination 9, comma 3, close, divided by combination 13, comma 3. I like to be able to see my numerator and denominator. Boom, same answer. Formatted to 3 decimal places. Bazinga. There you go, same answer, but I like to do it where I say, okay, that's what this is, that's what this is. See if we've got any more that are similar to this. On number 15, it says outside a home there is a 10-key keypad with letters A, B, C, D, E, F, G, H, I, and J that can be used to open the garage if the correct 10-letter code is entered. Each key may be used only once. How many codes are possible? There's a couple of ways you can look at this. You could look at it as a permutation of 10 picking 10. Really, you could. Equals permutation 10, comma 10. And I get, what is that, 3,628,800, and that is indeed correct. Let's make these a little larger. Oops. Now, so, again, what did I use? Permutation 10, comma 10. It could have also, since you were using all 10, I could have used just a factorial, 10 factorial. You're going to get the same answer. What I want you to see here is anytime you have a permutation where you're picking all of them, it's the same as a factorial. Mathematically, it has to be. Now, that's the answer to this one. But think about it. What if you had 10 possible letters and it was only a 2-letter code, but I only had 10 and I couldn't use any of them twice? How many different combinations or permutations could I have? Think about that. Let's see what it would be. Equals permutation 10 picking 2 is 90. All right, this is just an example here. First letter, second letter. Where does that 90 come from? I've got 10 letters to pick from for my first digit. This is another problem. Just an example. Just an example below. How many would that leave if I can't use them more than twice or more than once? 9. What is 10 times 9? 90. It's the same math involved. Same math. Finally, let's look at this last problem in the homework this week. A horse race has 10 entries and one person owns 2 of those horses. Assuming that there are no ties, what is the probability that those 2 horses finish first and second, regardless of order? All right, they don't say this, but it has to be implied that all of the horses have an equal chance of winning. It needs to be said, but it doesn't say it in this question. If he has 2 of the 10 horses, the probability that one of those will come in first, I'm just going to type this in quotations here, is 2 out of 10. Okay, that's one of them coming in first. The probability that the other, regardless of order, will come in second. He's only got 1 horse now to pick from out of the 9 that are left. So 2 out of 10 times 1 out of 9. Let's see what that is. Equals, we'll put it in parentheses, 2 divided by 10, which is of course 0.2, but I'm going to use the fractional form, times 1 divided by 9. Only had 1 horse left out of those 9, is 0.202, but let's make this a little bigger. 0.022222. Always, if you're using Excel, always pull it out and make sure you're getting the right level of accuracy. Let's see, round this to 4 decimal places. Format cells, number 4. 0.0222. Another example, let's say he had 3 horses. Say he had 3 horses in this race. What's the probability of them coming in first, second, and third, regardless of order? That would be equal to 3 divided by 10 times 2 divided by 9. There's only 9 horses left. 2 of them are his, times 1. Need that parentheses. 1 divided by 8. Let's see. Ooh, 0.01. Pull that out. Really, 0.0833. Anyway, the answer to my question there was 0.0222. Say there were 9 entries and a person owned 2 horses. It would be 2/9 times 1/8. Say there were 7 entries. It would be 2/7 times 1/7. Just probability there. Don't let it scare you. Take care.